Hi, folks. This is Sarbjeet. Today, I'm very excited, actually. I'm excited because I am talking to somebody I have been following all along when it comes to data science and big data and all things data science, you can call it, right? Machine learning, AI, and algos, and, you know, you name it. So I am excited to welcome Bill Schmarzo to uh, to my talk, and we're gonna talk about data science, the current state of data science, the the tooling, the platforms, the actors in the data science, the stakeholders and the vendors, and the economics of the data science. He wrote a book, which is his recent book. He has written a few books throughout his career. It's called Economics of Data Analytics and Digital Transformation. A lot of theories, economic theories mentioned. I am very passionate about economics, mix of economics and technology. Economics matters a lot because that's why we do these things. We want to do things faster, cheaper with automation. With that said, welcome, Bill.
Jeep, thanks for having me. I'm looking forward to this conversation. Our pre-workup layups and jumping jacks got me all fired up here for this conversation.
I know we talked like for 2-3 minutes about like what we're going to talk about, so we're warmed up. With that said, let's start with the current state of data science. It's a very loaded question. I want you to sort of lay out like how do you see data science progressing, the the different parts of it, practitioners and vendors and stuff like that. Then we'll go drill down into different areas.
Sure. So I think we're coming out of data science 1.0, where we were sort of fascinated with what we could do with technology, using deep learning and neural networks to recognize cats from dogs and dogs from wolves and things like that was pretty cool. And the natural language processing, getting them to sort of understand what we're saying, though always not really well. I think we're coming out of the we're amazed by the technology.
Mm-hmm.
And now we're entering, I'm going to call phase 2.0, data science 2.0, where now we need to start delivering value. So we need to move beyond the fact that we can do certain things to the point now where we really are delivering meaningful, quantifiable, and relevant business and operational value. And that means the data scientist, at least the data science team, has to morph. And I'm going to argue that I think the leading data scientists also need to morph, to spend less focus on the technology and more focus on really understanding where and how value is created for their stakeholders. And that requires a different skill set. It requires a different background. And not all data scientists are going to feel comfortable with this transition, and that's okay. But I think the ones who are going to be the leaders for tomorrow, are the ones who can take this really complicated machine learning, reinforcement learning, deep learning stuff, and simplify it in a manner that any stakeholder can understand what and how they can use it, and how it can help them, the stakeholders, derive new sources of value.
Yeah, I think what scares me every time I read this term data science is I'm from a small village in India, so I was always scared of science. So like I was made scared of science. Actually, I was not scared of science. I took math and economics in my bachelor's, and then I did master's in economics. So like why do we call it data science? I mean, like it's very philosophy kind of question. Like why? I think it should be data art or something else, like not data science. I mean, is it really science? Like how much are we scaring people away from this discipline by overcomplicating the terminology, the tools, and how hard it is to get into it or how easy it is? Because if you see, I've seen some I've done some basic. Okay, by the way, back up a little bit. I took econometrics during my master's, right? So I understand the sort of complex of the models and all that stuff. It can get complicated. Not everybody can look at those econometric models. I mean, at the end of the day, if you want to do the data science right, it's econometrics. It's a mix of math, statistics, and economics put together. I mean, that's what it is.
Yep.
and there are different ways, and there's time series analysis, and there are other type of analysis, and bunch of other sort of disciplines underneath that. It's a vast area, if you will. But having said that, I think it confuses the heck out of people who want to get started with the terminology and all that. So, like how, let me ask you this: how can we simplify this for practitioners and or the decision makers who are like not doing it hands on, but they make the decision like, oh, we want to put $5 million or $10 million to just do experimentation in this area or in my team and stuff like that.
Wow, well, that's a loaded question.
It is.
I don't believe that organizations should invest $5 million to experiment at this point in stage where we are with data and analytics. That's if that's where we were 10 years ago, and we've evolved beyond that. But you asked a really interesting question. Is it data science or is it data art? Let me ask you this question. Is your surgeon a scientist or an artist? If your surgeon's working on you, if you're having surgery on your heart or some part of your body, is that science or is it art?
And I always see it's both.
Yeah, I think when a doctor's working on you, they are making their decisions based on some scientific knowledge. But at the end of the day, they are applying art in the fact that it needs to be relevant to you because everybody's body is slightly different, right? Generally speaking, we're all the same, but once you get inside, there's slight differences, and we've accumulated injuries and diseases, and so we're all a little bit different. So if I think about a doctor and what a doctor does to understand the condition of the patient, understand what's important or of value to that patient, and then prescribes the right kinds of medicines and surgeries and treatments to solve that, you got me thinking, I think a data scientist is kind of like that. But a good doctor starts by really understanding the patient. What is it trying to do? In my case, I had ankle surgery a year and a half or so ago. I had messed up my ankle pretty badly playing basketball in college, and it will never be the same again. I will never be able to get off the ground like I could before. My basketball days are way down behind me. But I remember when I had the surgery, the doctor asked me lots of questions about, what do you want to do when you get out of it? Are you looking at skiing? You want to run? You're going to play basketball game? What's important to you as an outcome from the surgery? We had a long conversation. Then when he then prescribed what to do, it was really in alignment with what I wanted to do afterwards. And so is it data science or data art? And I'm going to say it's yes. It's a bit of both. There is obviously mathematical formulas behind a lot of the algorithms that are out there. There are scientific basis and there are economic theories behind a lot of this stuff. But at the end of the day, a good data scientist spends the time to understand what they're trying to achieve, what outcomes they're trying to drive, and then figures out what it is I need to do or my team needs to do in order to deliver that outcome. So the answer is it science or is it art? The answer is yes, it's both.
I'm glad you're keeping the answers to short so we can cover more ground. I think it's both. Yeah, I agree with you. On that note, I usually say that tech is like medicine. Like every pill has a side effect. Every technology has a side effect. Seriously, we implement data science and it will say, okay, oh no, we have bias now. We have to kill the bias, and we kill the bias, and it will create other problems, and then we will come up with another technology. So keeping that in mind, that every pill has a side effect.
I think you're trying to ask what are this fascination with data science can make us lazy about how we are considering the outputs that come from these models.
Yeah. Okay. Let me reset this.
Good.
The idea came back to me. So I usually say that tech is like medicine, right? And like in medicine, every pill has a side effect. In tech, it's a similar thing. We implement one technology and then it creates problems. Like in data science, there's a lot of talk about ethics and explainable models versus interpretable models and stuff like that, right? So having said that, and also like I extend the analogy in tech with medicine further. There's over-the-counter medicine, right? We usually take, the Tylenol and stuff like that. And there's prescribed medicine, right? And then on top of that, even that, if the medicine doesn't work, we go for a more diagnosis, and then maybe surgery, as you mentioned. But that surgery thing brought this whole idea to my mind that we should cover it that way. I love the analogies. So I'm seeing a rise of pre-built data models. The marketplaces, Amazon has a marketplace where they're parking pre-built data models for different domains. um, I'm a big fan of abstraction because I started my career as a coder, um, and abstraction is your friend when you're building systems, right?
Certainly. Yep.
So I think pre-built models. I want to get your take on the pre-built models, like consume the off-the-shelf or over-the-counter like data science versus prescription data science versus surgery. If you can shed some light on those like three different like segments, uh, that'll be good, I guess.
So again, a really loaded question. So as you describe, as you describe the medicine analogy of OTC, over the counter versus prescribed, the first thing that popped to me is that over the counter is like BI,
Mm-hmm.
that I can have standardized reports and dashboards that tell me what's going on, and I can probably build a standardized dashboard on logistics or shipping or whatever it is, and it probably is going to work for 90% of my audience. It's over the counter. But when I get into prescriptions, then I'm really getting into data science. And when I get into prescriptions, I need to become very individualized aware. While OTCs can be very over-the-counter drugs, can be very generalized and work for the mass on average. When I start getting into the prescriptive environment, I need to get much more laser focused. And that's what we're seeing with a lot of these more granular prescriptions that we're going out in the market with, right? So using that as the basis of how I think about things, and how, to me, data science is about being very prescriptive about what we're doing, very prescriptive recommendations at the level of each individual, whether it be an individual human or an individual device. I think pre-built analytic modules are a great aspiration. I can see a marketplace evolving for some generalized pre-built models, things that are usable by everybody, maybe something like anomaly detection. The world's best anomaly detection can be used for, IoT on compressors and wind turbines, can be used on customer transactions for fraud or for attrition.
Yep.
So you can see that there's probably a market for these pre-built models that you're going to then need to have to add others on. It's kind of like, this is a really bad analogy, but you got like this, they give you a few Lego blocks, but then you got to build the other Lego blocks, because everybody's business is slightly different. Everybody has different objectives, different dimensions around which they're creating value. So I do think that having pre-built models will allow people to more quickly become more data centric. I don't think it solves the problem. It's kind of like the conversation around auto ML. I love a lot of aspects of auto ML. I think are great. They do help jumpstart the process, but they don't solve the problem. They don't. I mean, if I have a headache, over-the-counter medicine probably works great. But if I have an ankle surgery, I can pop as much aspirin as I want, and it isn't going to help. Blush me, I tried that, right? And so, I do think as the problems get more complex, that we will see increase in sort of the capabilities being provided generically. That just means that differentiation is moving up higher. That you no longer differentiate maybe on, you're the best anomaly detection, you're best at identifying when a customer is going to try. Well, maybe if everybody's using the same anomaly detection module, maybe I do want to become better there. Maybe that's, I don't want to be average in those spaces. And so when you move down the path of packaged analytics, you're moving down the path of accepting average performance, because everybody's going to have it. To me, it's like the frustration with ERP systems. How much money people spend on ERP systems as if that was going to give them differentiation. But let's be honest, no one buys a customer's product because they got a better HR package? No one, right? So anyway.
Yeah, I like the space layered approach, which Gartner came up with. I kind of extended that to the cloud consumption. There are three types of systems at any company: systems of record, systems of engagement. I sometimes call systems of engagement as systems of differentiation. And the third tier is the systems of innovation, right? Three tiers of systems, right? I Now I'm talking to you. I want to say that we should have three type of systems in data science. So data science for systems of records, right? Right. We can
Yep.
improve anomaly detection, fraud detection, all that. It goes against the data which is sitting in the system of record, and that can be a lot of that can be pre-built models, right?
Yep.
So when it comes to the systems of engagement or systems of differentiation, you're Ford, you have your different, you do CRM differently than GM or Chrysler does, or VW does, or Mercedes does, right? So they differentiate that level. Everybody has HR, everybody has sort of P&L systems and financials. They all do same. Who cares, right? But when it comes to Service Cloud or CRM kind of applications, how you how you automate your factory at Tesla versus Ford. We know that their robots are programmed, how they are programmed. They differentiate, right? So in that middle tier, there's a lot of, I would say prescribed kind of, in my analogy, prescribed medicine, prescribed data science, if you will. And the third tier is the systems of innovation, which is greenfield, new, you know, new breed of applications. That's AR, that's virtual reality, that's a lot of data from all the video and NLP and all that stuff, right? And that's almost kind of to me, it's like the surgery. Like you start something new, it's like you can refactor your systems and you can change the data structures, because at the end of the day, what do you feed the data science is data, right? If your data is not um, pristine or clean to be used, I mean, you can only go so far, right? So where I'm going with that is, I think there's a room for all these different types of sort of data science consumption, if you will. I'm a big fan of consumption economics. Like, how do you consume something, right? How do you start consuming something? Where do you start? I think there's a way you can ease into doing the data science, right? Um, I'm not saying that the over the counter will help you. It can actually make you lazy. You can get addicted to it, and it can have over the counter has its own side effects. We know
Right.
that.
Right.
We know that, right? So prescription is better most of the time when you have severe sort of problems. So um, I think in that context, how do people start? How do we shed some light? Like, what are the problems? You talk to the practitioners all the time, and your students, you teach there, and also in the industry, you give sort of your talks, and you talk to the leaders in this space. What are the main problems people face, and how do they overcome that? Let's put it that way.
So a couple of points. So I like your three levels. let me simplify first and then come back to. So to me, smart organizations buy for parity and they build for differentiation.
Mhm.
Period. Right. If I was a CEO of a company, I'd buy my HR system.
Yeah.
Right. I'd buy my accounting systems and such. I wouldn't build those. Right.
Yeah.
And most smart organizations they don't do that. Right. And so you buy for parity and you build for differentiation. And by the way, that line of demarcation between them is changing,
Yeah.
right? What the parity starts to move up as more and more parity exists. And as a company, if what you formerly had as differentiation now becomes parity, you're better off to buy what they had, and then spend your valuable resources, invest your valuable resources on creating new areas of differentiation,
Yeah.
which gets into that level 3 innovation. So let's think about innovation for a second. we tend to get enamored from an innovation perspective by technology. But we don't always think about where and how we are using that technology to derive value. For example, if I there's three dimensions which I would say if I'm looking at trying to drive innovation, I'm looking at three areas first, and then I'm trying to figure out how technology has. So first off, I want to enable new business models. That's an innovation, right?
Yes.
Number two, I want to reinvent business processes. I want to take out inefficiencies and exploit the areas of value creation. Number three, I want to disintermediate customer relationships. So those three things, those are things, if I'm thinking about innovation, new business models, reinventing business processes, disintermediating customer relationships. Now I can take a look at technology and say, which of these technologies help me? Yeah. AR, VR, does that help me create new business models? So now I have a basis, because I think, and there's probably other innovation models too, but those three always jump out at me because I know I can apply data and analytics to all three of those in a way to achieve success. But if I don't know what I'm trying to do, if I don't have a vision of the business model, and by the way, business models, enabling new business models, reinventing business processes, and disintermediating customer relationships, those conversations don't start with technology, they end with technology. They start by understanding the customers and the market, and a lot of these design thinking techniques like customer journey maps and service design templates and personas and everything else in those space here. It starts with an intimate understanding of your customers and the market in which they reside, and drilling down into how those customers are creating and enjoying value and the impediments to value creation. And then I target that with technology. So I take a slightly different spin on the technology. To me is I was and probably still am the industry's worst chief technology officer. When I was chief technology officer at Dell EMC, I was the worst one. You know why? Because I don't give a shit about technology, right? I care about how I'm trying to create value, and then I drag technology to help me do that. But if I get fascinated with technology, then I'm just chasing the next shiny little thing. That's not what's important. Anyway, so I'm beating that dead horse.
Yeah, I think deep about these things, by the way. I think it's both. We business should lead it, but we need to have the knowledge about what technologies are coming down the pike and where they are converging, so we can leverage them. We gotta know the technology, but at the same time, the focus should be like, how do we improve our business and or greater good if it's nonprofit area or the government area, because we use technology all over the place.
Can I add to that? So you're spot on. The technologists can't do that by themselves. They have to have that collaboration. And the one tool that I found that it's worked for me over and over again, no matter what size of client, no matter what industry they're in, whether it's profit or no profit, is how you work with customers to envision the realm of what's possible with these technologies.
Exactly.
This envisioning process is not a technology-driven envision. It's an envisioning around business models, business processes, and customer relationships. And if you drive that from an envisioning perspective, and that's lots of flip charts and whiteboards and post-it notes, and really spending a lot of time up front to really understand where is value created today, and how do I define value, and where will value be created tomorrow, and how do I define it? Let me drill in a second. Defining value has changed. Mm-hmm. How we define value has changed in the last year or so. We're starting to see that financial has always been a key source, right? You got an ROI and all that other BS, right? But now we're starting to see conversation around environmental concerns and diversity concerns and social concerns, right? So all of a sudden now organizations are starting to look at value from a broader perspective. If you're trying to understand how you can envision where and how technology can help you from a value creation perspective, your definition of value is the first thing you need to examine and make sure you've thought about it more broadly.
Again, I come from this pure software development background, and Grady Booch, I'm a big fan of him. He wrote books on object-oriented.
Yeah, I read Grady stuff. Yeah.
I sometimes interact with him on Twitter. He lives in Hawaii now, he has a quote. He said, "A fool with a tool is still a fool." I love that.
Yeah,
A
that's a good
fool with
point.
a tool is still a fool, and technology is just tools, right?
Amen.
So yeah, so we have to be business savvy to use the tools, right? So another sort of famous kind of meme kind of floating around is like, I don't need a hammer, I need nail in the wall, you know. So it doesn't matter like how do you get there, like, data sciences means to get somewhere. And by the way, on talking about the innovation, to our viewers, Bill, you might be aware of this. There's a great book called 10 Types of Innovation. I was like, it's
Yes.
an eye opener. It was an eye opener for me. I thought like I knew most of the sides of the innovation because I read a lot on it. I have interviewed people in that space, from Harvard University, which is the home of, theory of disruption, if you will. That it came from there. Um, but this book opened my eyes to sort of all other different aspects. There's a channel innovation. That's distribution innovation. There's a service innovation. Like you can do service better than others. You can do distribution better than others. You can break your product into smaller chunks. And I usually call it, it's age of micro consumption. That means it's age of micro production. You have to produce your things in smaller chunks. And also, it's a business model innovation, like from capex to opex kind of stuff, like we do in cloud and other cars. You don't need to buy now; you can just get the service. With Uber and Airbnb. Airbnb is like capex to opex kind of shift, if you will.
Right. Right.
I put that under micro consumption. Even in the technology, in the smallest of those technologies, if you look at our smartphones, like these guys, which are like supercomputers in our pockets, the best applications, the application which like really take off, are the ones which do one thing and one thing well. You try to do two things in an app, it fails,
Yeah.
right?
Yeah.
So it's age of micro consumption. And on that note, look, I'm just free floating right now here,
Sure.
like in my ideas. I think that in the data science as well, I believe, actually, I was talking to some data scientists and all that stuff on Clubhouse. I mean, there's the great groups talking about data science and all that stuff. It's a new freaking medium to get
Just so we
sucked
need
into.
another medium. Yeah. Oh, hallelujah. Right.
It's awesome, by the way. It's awesome. I love it because the long form, the room can run for like 2, 3, 4, 10 hours sometimes, and you can plug in whenever you want, and then you can learn and say a couple of things and validate your ideas. It's great. They're experts from different companies. I was talking to different folks from like Microsoft and Intel, and like how the hardware acceleration helps in the machine learning and all this stuff. So and there's CUDA, and then the TPUs, CPU versus GPU, all that stuff. It's really fascinating. Yeah, I think on coming back to the micro versus macro, I think if we can, I asked them the question, like, I believe, okay, let's back up a little bit. So the difference between programming and data science. Programming was automation, 1.0 you can call it, or 2.0, whatever you call. But the machine learning is the next level. With machine learning, we want machines to program themselves. Like that's what it is, right? We don't want to have if
Right.
then
Right.
else, all that stuff. We don't want to have the for loops like coded, hard coded, right? So we want machines to learn, and then that means code themselves, right? um, and then in that sort of rhyme of things, if we have these micro models which they solve one problem, it's very like sort of narrow set of problem, like it can be anomaly detection, fraud detection in credit card industry, or finding anomaly in the when you're looking at x-rays or blood samples, different domains, right? So it's a set of like micro smaller models, and then there's a composite of different models, and there's a relationship between models. I think that I see data science evolving that way. It has to be that way because I think the smartest system is the one which can take into account most number of variables while making a decision. That's our brain, right?
Right.
So we always talk about, can we mimic our brain in machines, right? Data science, ML, AI, you know, we progress in that sort of order, if you will. Um, so putting a lot of variables into a model, right? We call it those features, right? It complicates things like exponentially, as you know that, right?
Right.
So how do we make these nested models? Like, how do we create models of models, if you will? Did you work in that area, or like what is the progress being made in that area?
It sort of, what's the progress being made in what area?
Models of models, you know.
Models of models. So ideally, a model continuously learns, right?
Yeah.
And you may give it 100 variables against which to test, but it's going to seek to optimize and maybe identify that I don't need 100, I need 3 or 4. There is a lot of benefit for having fewer variables that predict versus more. For one thing, if I have to rely on 100 variables, 100 different data sources to get a particular answer, that means there's 100 data sources against which I need to do data governance and data management, which are very expensive, time-consuming efforts. If I get the same result or nearly the same result from three data sets, I'm much better optimized, right? That's the key is, how do I do more with less? That is overall our challenge from the world going forward, but I think here as well. So the beauty of auto ML is its ability to test a whole bunch of different types of algorithms to see which ones are most relevant. And then it also tests, what metrics are most very valuable. And in some cases, even probably will get to a point where they'll be able to do some standardized data transformations to create composite metrics out of the metrics they have. Again, all exploring. It's a try, fail, learn, try again kind of environment. And to me, that's the most compelling thing about these learning systems like reinforcement learning or deep learning, and some aspects of machine learning. Machine learning has all kinds of other, that's an overused term by the machine learning. So I kind of walk softly on that one, but I like these environments that can continuously try to learn. The reason why that's important is versus the if-then statements is because the world changes. Yeah. A new breed of dog comes out, and it didn't fit into your if-then statements, but your new models are based on a deep learning rhythm can figure out eventually that's a dog. That's not a cat. That's not, it's not a rat, right? And so these systems that continuously learn, that's what's really powerful about this. But again, I'm off on a slight tangent here. Against what are you trying to learn? That is, what is the AI utility function that I'm trying to optimize in that learning process? Recognizing dogs and cats from cats is pretty easy, but as we start getting into more advanced areas like autonomous vehicles, we need to start taking into consideration a wider range of variables against what you're going to optimize. That's where I think these deep learning systems and these reinforcement learning systems really start to shine, is that the values you're using and putting in these things are way beyond what we ever could have done in an if-then statement. And you can continuously learn and tweak these things. We can take and we can start to weigh more heavily environmental issues or social issues into our models and coming up with solutions. We know that today, a lot of the AI models that are being used to decide who gets loans, who gets a job, who gets accepted by colleges are highly biased because they're only optimizing on a few number of variables. Yeah. The social media sites are horribly biased because they support confirmation bias, and if you click on an article, you're going to get a whole shitload more of those same articles because they don't value things like diversity and serendipity and other perspectives out there. So I'm giving you a long-winded answer to this. I think the models, the techniques out there, things like auto ML and such, are going to help to figure out which is the right algorithms apply in a situation. But it's going to be up to us humans to figure out what are the what's the AI utility function? What are the values around what you're trying to optimize? And to think carefully around that so we don't have AI models that suffer from confirmation bias, that deny people loans that should get it in the long-term term, let Terminators roam up and down the streets here and wiping out humans because we didn't define our utility function properly.
Yeah, no, I think you're spot on. And because your answer is long-winded because I asked a freaking long-winded question. So that's why.
Well, and the question had lots of these are hard questions. We talk about the challenge of simplifying.
Yeah.
And I do think that's the biggest problem our profession faces today.
Yeah.
Is that we need to take the time to really look at the words we're using and make sure we're clear with it. As you know, I just taught a class the past 3 weeks at Menlo College, face-to-face with students. It was great, right? It was finally humans. And there was an undergraduate class.
Awesome.
And I was teaching them the thinking like a data scientist process, something I've taught to graduate students and a lot of corporations and how to think like a data scientist, but I never taught it to undergrads.
Mm-hmm.
It was a hard challenge for me. I spent a lot of time preparing for the class and then preparing the next week to correct what I told them the previous week, because I had to greatly simplify things I was saying. Let me give you an example. I always talk about the power of analytic scores to help aid in decision-making. I asked the students there, how many of you know what a FICO score is?
Yeah.
Not a single hand went up.
Oh my God.
You don't know what a credit score is? No. Okay. So I had made this big, broad assumption that when I ever talk about scores, I can say, yeah, it's like a credit score.
Yeah.
But now I had to really understand, I had to communicate to the students in as simple a way as possible about what is a score? What is it comprised of? And how does one use it? And we ended up in the class, by the way, pretty fun. We ended up as a group exercise creating a COVID at risk of dying score. Right. And what variables you might want to bring in. And we brainstormed that and how you weigh them. And so just kind of idea there. I learned a lot from that because I was forced to take something that I took for granted. One of my like one of my models said assumption this, and that was wrong in my model.
Yeah, I think did we say that before we started recording or maybe during the talk? Anybody who wants to do a big service in the data science space, they can, simplify things or uncomplicate it, because it's complicated. If you see the data science learning path, those trees and branches, the people use these tools to create it. I think I've seen a couple of them. I will put that in the video actually when I process it. It overwhelms you. You have to learn, R, Python, this, that, TensorFlow, all this PyTorch, five gazillion things. And we have to start at fundamentals. Actually, on that funny note, actually, as you said, like you were teaching the undergrads, and forget about undergrads, I had to join a KidCon. I spoke to a 9-year-old AWS certified kid, 9-year-old, at 2 years back at AWS reInvent, right? His name is Karthik. And this year, he's 11 and a half or so, right? He created KidCon. He said, sir, I want you to be my guest. Of course, I talked to his parents as well. Like, he's not just doing all this stuff on his own. And I was so terrified to talk. I mean, I can talk to my peers, and because I make some assumption and they are at a certain level, I had to talk at their level, the kids' level. And they were asking me, what's the future of the cloud? I mean, like, oh my God, how do I explain it to them?
Yeah.
Right.
Yeah.
And how do we start learning about cloud? And I had to say, there's a book called How Internet Works. You need to know basics, like the data travels over the wire.
Yeah.
There are wires under the ocean. If there's fiber optic, I'm
Yeah.
like,
Yeah.
what should I say? Like we build our blind spots, and my feedback to you, because I read a lot of your stuff, is my humble request to you is to simplify what you say.
Right.
I love the fact that you weave in economic theories, scarcity and price elasticity of demand, and price elasticity of technology in general. I talk about those things too in cloud context, if you will. Those are great, actually. I think if we can just help the practitioners to simplify stuff, and that's where I was going with the micro versus macro. Like you can start with the micro models, and then you build on top of it,
Yeah.
right?
Yeah.
And keep improving. And in that context, I think I'm trying to explain to you the problems of the people who don't do data science every day and they want to do it. That's me. One of those people is me. Is that I hear all the time that there's a training of the model and there's inference. Training, inference. Those are two different things. You train the model with the data and then you put that in production and it's inferring from that.
Right.
It's
Right.
like getting the results. And what you are talking about is that's how I see the data science. What you are talking about, continuous learning. We use that sort of continuous CDCI in different contexts, in DevOps context, that. But I think in the data science context, like a lot less people talk about continuous learning. Maybe they do, I don't know. Maybe I'm not aware of those. But I think continuous learning is the key. And forget about continuous, don't call it continuous learning, or maybe call it continuous learning, but unlearning is part of the learning,
Right.
which I deeply think about, like how does our mind work. I don't remember all the things I did yesterday, like all the things, like in like uh, 14 15 hour long day I was doing something. I drank tea, I ate this much and I walked that much, da, da, da. Yeah, I took step here, left here, right there, so I don't keep track of all that. But the problem with the machines is they do, right? They do remember everything. And then how do we make them forget certain things and keep only a few things in mind? That means in data. That is key. I think there's a lot of data exhaust out there, which we tend to chase every sort of strand of data. I think we need to be very smart about um, processing the data at the node of the sort of which produces the data. And now I'm going into IoT and edge kind of cases, but edge kind of sort of implementations, edge computing. I believe that we need more models for um, distributed computing, and then only if some data from these nodes come to the central repositories where we do another type of data science or another sort of type of analysis on top of that data. So I don't know. I'm all over the place, to be honest with you. But
No,
like,
I think your example here is that there's learning at different levels.
yeah, okay.
There's if I think about a Tesla.
Mm-hmm.
So Tesla has an analytic module called FSD, the fully self-driving analytic module, which is their autonomous vehicle
Driving, yeah.
module, right? And it's over time, every car that's driving around, that module is running. Whether the driver turns it on or not. If the driver doesn't turn it on, then it runs in shadow mode, and it's trying to learn from that particular driver best
Mm-hmm.
practices, right? It's every car is learning. 1 million of these cars are learning, and what happens at the end of each night, or is that all the learnings from each of those individual cars gets pushed back up to the cloud,
Yeah.
gets aggregated, and then back propagated back down to all the other cars, so that
Yes.
any one thing that one car has learned in a particular situation, every car now has learned that as well.
Yeah.
And that's almost tiered learning. There's learning at the individual entity level, and then there's the integration at the holistic level and pushing that back down.
That's awesome.
So there is this continuous learning thing is really critical.
Mm-hmm.
And the unlearning part is, so when I'm developing the model, I am using the cost of false positive and false negatives to tell me when a model is good enough. Because when you develop models, you run into what we call saddle points, which is the model you put together with the data sources and the transformation and the feature engineering. Let's say that based on the cost of the false positive and false negatives, your model needs to be at a 92% accuracy level or recall, right? You can't get there.
Yeah.
No matter what you do with those data sources, no matter how you munge them, and you just can't be above 85. Just can't do it. Sometimes you need to go all the way back to ground zero and start all over again. Learn from what you did before it didn't work and try something different. But sometimes you got to tear it all down and start all over again. That's a hard process, but you hit these saddle points and the model just won't get any better. So you don't know when you've reached a saddle point. You don't know when a model is good enough unless you know the cost of the false positives and false negatives.
Yeah.
The determination of the cost of the false positives and false negatives isn't something the machines are going to do. It's something the humans need to be involved in. We need to be able to understand, again, I'm getting back to the same point of the AI utility function, how we holistically define that so that we try to minimize unintended consequences. We try to minimize confirmation bias in the model so that we've got this thorough thing there. And there will be points in time when those utility function will change. What we think is most valuable will change. There might be economic changes where the price of oil does this, or the carbon does this, or we have these kinds of social unrest. The models are going to continuously change, and those tweaks, humans got to control those. We have to tell the AI models what they need to do. Otherwise, we're just abdicating our life to them, and that's not very realistic. So I think this unlearning thing is critical, but it applies more to us as humans and our ability and our willingness to basically say, that model was right for that time in life, that time in the world. During the pandemic, our models changed, and they're going to change again in 4 to 6 months as the vaccine comes out. And then they're going to change back again when we have something new happen, a new kind of pandemic or catastrophe, or, aliens attacking the planet, something like this, right? So humans can't wash their hands of these models. We need to be constantly monitoring them, tracking them. And when we get down to the cost of the false positive and false negative, I'm sorry to drill in this, but it's really critical.
Yeah, that's good stuff.
The false positives, that is, you decided, the model said hire this person, you hired them and they bombed out. You have the data on that, so you can feed that back to your model. So the model says, oh, people like this are, they get weighted differently. It's the false negatives. It's the false negatives that's really hard. The person you didn't hire who went on to do great things, the person you didn't give a loan to who ended up repaying that loan, that student you didn't admit who goes on somewhere else and becomes Einstein, right? These are the things. The false negatives are hard.
Those are unknown unknowns.
They're the unknown unknowns. They're the things that we didn't take an action on, and we need to figure out if that not taking an action was the right decision. Sort of we don't know, how do we track the person we didn't hire and see what they did? But if you want your AI model to be efficient, to continuously learn and adapt, you need to instrument everybody you've interviewed and didn't hire, figure out what they did. Maybe you track them on LinkedIn, maybe you send them surveys, I don't know. But otherwise the AI model is going to continuously drift. It's going to suffer from confirmation bias. It's going to continue to hire the same people it's always hired because you don't know what you don't know.
Yeah, exactly. I think who said that? Mike Tyson? Everybody has a plan till the time you get punched in the face.
That was Mike Tyson. Yeah. Yep.
Yeah, somebody said that. So I mean, like, our models kind of flopped in 2008. Our financial models, actually, in finance, this data modeling is a very old thing. They have been doing it for a long time, and that's the investment models, they call them. And they fell apart in 2008. Market tanks, and then all these automated trading systems, it reels down and there's boom, right? And now during pandemic, the same thing happened. Our supply chains were automated to most extent, and then our stock markets and high frequency trading and all that stuff, it just fell apart. Things unreal, like in a unpredictable way. In spite of all these advancements in the data science and automation and all the systems in place, right? I think our ability to interject at a certain point and take control of these things is very important, and that's the one fear personally I have. Like, it's not like I'm losing sleep over it, but like, if we do too much automation and we can't interject, and machines cannot take into account all the variables at play. I think we need that level of introduction
So
in these systems.
we do. And here's the thing about it is in the financial meltdown, and was it 2008, there were people who were predicting it to happen. There were some people, there's a movie made about it, right? That these folks, that they said the market was totally overvalued. They looked at a couple of very simple variables, percentage of people's income being spent on mortgages, and the value of a house relative to an income level in an area. I mean, they could circle in that these areas are way overexposed. The challenge we've got isn't that we can't identify these black swan events. It's making sure that we've got a broad enough net that we're swooping out there to capture people who have these ideas and theories, who can start flagging this. I mean, there are people out there who said this pandemic was going to be what it was, right? And the models horribly missed the fact, right? Because, well, people took political pleasure in skewing them one way or another. But the only way to really make certain your models are comprehensive in their ability to make decisions is to make certain that you have cast a wide enough net of people so you can go out and you can identify and start to think about, well, these are the black swan events that might happen, and factor those into the AI models so that you don't, for example, overexpose yourself in loans, or overexpose yourself in unpreparedness for vaccinations, and our supply chain, and how it was really unprepared. As you said, we had the whole just-in-time distribution and manufacturing processes, a supply chain hadn't taken into account all these other variables, the risks associated with them. Again, a lot of this is associated with risk and the false positives and the false negatives, things you didn't plan on happening, didn't even measure. You didn't even friggin' measure it to think to happen. And then when it happens, you're caught with your pants down around your ankles.
Yeah, I don't want to go to this tangent, but I talk a lot about
We're heading down lots of tangents. This is fun.
A lot of tangent. There's a greed factor, right? There's with that comes the regulations. We know what happened back then, right? There was a lecture being given at again, coming back to MIT. I follow a lot of their teachings and from bigger schools or known universities. I watch that stuff, and I think it was Jeff Bezos or somebody like that, luminary, talking to the students, and then he said one thing in there, sometimes it hits you. He said, what percentage of your product is software, right? That's a totally different way to look at things. He said, let me give you, I think it was Jeff Bezos. He said, let me give you an example. In Wall Street, the products are just an idea on the paper and software. That's
right.
it.
Yeah.
Those are the products. They don't make anything tangible.
Right.
The derivatives, the swaps, all these things, the financial instruments, they call them, right? They're all ideas on paper and then software, right?
Right.
So they just do software, exchanges of funds this way, that they move billions of dollars, sometimes trillions of dollars a day through the wires of these computers, right? And they move markets. They're market makers and all kind of stuff, mumbo jumbo, which I study from time to time. But long story short, the fact that we let the creativity cuts both ways, right? It's a double-edged sword. So these people who can get greedy, they can be creative about making money. It's the job of regulators to make sure that we're not going, wild. You look what happened recently in the market. It's happening today too.
Yeah.
For the last 4 or 5 weeks, there are some kids on social media sites, right? And they're hyping up the GameStop stock like crazy, and it was highly shorted. Now it's way up, and the SEC is involved. They don't know what to do. Like, they can disrupt the whole freaking stock market sort of system, if you will. It's kind of shaking a little bit, like, okay, my God, what do we do? So I mean, there's a danger of letting automation take over, or ideas all these creative people like just exploiting the loopholes in the systems and stuff like that. Where I'm going with that is like I had a bullet point to talk about. Let's wrap up our conversation about the
Okay.
regulators. What's the role of regulators in the data sovereignty, data privacy issues? Like, why I'm coming up with that question is like I hear a lot from the data scientist community, people who are very passionate about it in the healthcare industry, for example, and some other, and also in financials. They want to build the models and they want to solve the complex problems. That they always say that we don't have access to data. Access to the raw material, to the ingredients, is a must for any industry to take off, right? So I know that Kaiser donated some data on the DNA side, and there's a DNA data bank from Stanford, I guess. You can correct me if wrong if you know about that. There are data banks being made open after anonymizing that data, if you will. So the role of regulators and availability of data, your views.
When I think about regulators, I think about playing basketball. And here's what when I go to play basketball, here's what I want. I want to know what the rules are. Where's the 3-point line? Where's the out of bounds line? Where's the 10-second line? I want to know where they are, and I want them to be consistent.
Yeah.
So I want rules that make it equal for everybody to play. We're all playing under the same rules. I want the referees have consistent application of those rules, right? If I travel, I travel, right? You don't do like LeBron James does his crab walk, which takes about 9 steps. That's a travel, but he gets away with it, right? And so I want the consistent application of the rules, regardless of who I am. So I want to know what the rules are, consistent, and I want the consistent application. And then finally, I want the transparency into how I'm measuring that. So when I think about regulators, they do 3 things. They define the rules to create a level playing field so no one has an unfair advantage. They are consistent in the application of the rules, and they provide transparency in how they're measuring. That's what a regulator does. If you don't do all those 3 things, then you're going to end up with somebody having an unfair advantage, going to take advantage of the system. If they're not making the measures transparent and how they're making decisions and how they're the application of the rules, then you're going to have people who are going to find ways to game the system. So to me, regulators do those 3 things: define the rules, consistent application, and transparency in how the rules are being measured and tracked.
But do you agree that the regulators are always behind the curve when it comes to latest technology?
Of course. I mean, how can they make rules about things they don't know about?
Yes.
I mean, what's happening is that most of the time, a lot of these new technologies come up because they know what the rules are, and they're going to use technology to find a way around that, legally in most cases. But they're going to find a way around. They're going to play within the rules that are defined to them.
Yes.
And so the regulator's job is they're playing a game of whack-a-mole. They're always after the fact trying to tamp these things down. You can't make regulations for problems you don't even know exist yet.
Yeah, we talked about this. The gap between what we teach at the universities and the data, coming back to the data science sort of discipline, and what we practice out there. I think same thing applies to. It's different in different countries. It's different within the country. We talked about it earlier a little bit. The same thing applies to the gap between regulators, like what they know versus what industry is doing currently. What do you think we need to do to mend that gap or to reduce that gap? I have some ideas, but I want to hear from you first, and then tell my idea so I can look.
So we talk about the gap between academia and the business world.
Academia and business, and that one, and also let's talk about that a little bit, and then also the gap between what regulators know, like their knowledge level about industry, and then what industry does.
So you've answered what you made the point I was going to make, that what we need to do is we need to shrink the gap between academia, which is developing lots of theory, And theory isn't just being developed in academia, it's being developed inside some size organizations.
Yeah.
So the world of where ideas are being fermented, which is academia and research sites, businesses that are trying to leverage those developments to create money,
Yeah.
and the regulators who are trying to make sure there's a level playing field. You have to have a consortium of all three that are working together. Now, I won't go into the fact that some of the regulators are maybe not as well educated as some of the business people are trying to take advantage of it, or the academia or the researchers are creating it. That's a key thing. The researchers who are coming up with the new ideas, which is typical academia, but not always.
Yeah.
The businesses that are trying to monetize those new ideas, and the regulators are trying to create a level playing field. You need to have all three of those involved in the conversation at the same time. That doesn't happen today. At best, we talk about here in Silicon Valley, the research is being done by academia, and the application of that research by business is a small gap, right, in the Silicon Valley here, because they do work closely, and regulators are playing catch up. You don't see Stanford and MIT and Cal and other schools bringing regulators in to the process of day one, right? They're forced to chase after the fact.
Yeah.
So it's a really hard problem, and if we don't, I keep coming back to the same answer. If we don't think more holistically around how we are creating value and how value is defined, then the regulators are going to always find themselves on the outside looking in. But if the regulators are a big part about what's defining value, if they put in place a carbon tax, that has a big impact on the value creation equation for, for a car and automotive truck manufacturers and airlines and everybody else. So I don't think in my lifetime I'll ever see those three groups around the same table trying to solve problems before they become problems. It would take a selfless kind of world to do that. And maybe that's the kind of world we see in Star Trek, but we don't see that in real world.
Yeah, I think we do see that. By the way, Gensler, who's going to be chairman under Biden, he was a regulator earlier, and then he taught Bitcoin and crypto at he taught a class at MIT. And I was fascinated. Whole class is online. By the way, I will put the link in the video, folks who are watching. I mean, watch the 26 classes. It's like 30 plus hours. Man, it's pure gold, if you will, if you want to learn about where we are headed in digital currencies and tokenization and whatnot. And they dig deep down. They don't have all the answers. The brightest minds they come to the class. People from the industry come to the class, and they present there. So that's happening. When I say I have it happens. Like I used to, after I finished my master, I wanted to pursue my PhD program. I ended up working with a think tank in India, socio-economic think tank. We have think tanks in the political sphere. We have the Hoovers and other think tanks in the U.S. And globally, and we have in economics, we have in the political sort of sphere, but we don't have think tanks in tech. Did you notice that? Do you notice
that's a good point? Yeah,
I am trying to create one. To be honest with you, I'm trying to shake people up. Like, we need at least one think tank in US, which is very close to technology on one side, and then on the other side they are closer to academia, and like it's a like less thicker line there, but they are closer to technology on one side, and then regulators on the other. Academia is always like there. To consult with, if you will. I think that will work. Actually, that can be sponsored by public private money, by grants and funding. That's how think tanks work. Actually, they get grants to do studies and all that stuff. So that's what my idea is. That's my forward.
It sounds like a good idea. I do think that again, it's not just academia. It's any research organization.
Yeah,
We do tend to primarily look at academia. because it's supposedly more public.
Yeah.
But there are research being done by a lot of non-public entities that are having impact that regulators need to be aware of so they can act accordingly.
Oh yeah, there's a lot of research in these companies which are private in a way, but they're publicly traded. But they're private company. There's a lot of research at Google you know how many economists um,
Yeah, Google's got a boat. I mean, and
Google gets like, and then
and the venture capitalists are all about
like,
helping to fund new research and ideas.
yeah, and Amazon, so there's a lot of research there. So like how they do stuff or what they're coming up with, and keeping these regulators on and lawmakers at the same time. So actually, we are approaching our like last 5 minutes. I want to hear from you your sort of departing remarks and the tips or tricks. And I know we have gone all over the place a little bit. I like it that these talks that way. I hope some people will get something out of it. Even if like 5 people get some good ideas from it, and then they follow up, and then they create something new. That's a good payback for these kind of efforts, I think.
Yeah.
What are your departing?
So my ending points.
Yeah.
I think the couple of things that popped to mind: simplify wherever possible.
Yeah.
Don't overcomplicate it. We need to create more awareness across more people about what's going on in this space, so they're not scared of it. We have a lot of people who are confused by it, and if they're confused by it, they're scared. If they're scared, they won't act on it. And I think we have an opportunity in the area of AI, data science, machine learning, data engineering, this space to really leverage data and analytics to really create much more informed and make much more informed policy and operational decisions. So there's this need to simplify the conversation and quit trying to overcomplicate it. And the second thing I would hammer on is both AI and economics have utility functions. How we define those define who we are. And if we're only defining those based on financial metrics, ROI and clicks and views, we're going to end up with all sorts of unintended consequences and all kinds of biases in the results of the models. We need to think more holistically. And that means having and embracing people who have different perspectives. So a diverse set of perspectives becomes really critical on bringing into this conversation. The conversations have been very much one-sided most of the time. We need to broaden that. And I think that goes hand in hand with the first point. If you simplify the concepts, you can bring more people into the conversation. So you have a more holistic utility function against what you're trying to optimize. They go hand in hand. Bringing in diverse perspectives is critical, is necessary to have simplified the technology so people can feel comfortable having conversations about it.
I think those are great remarks. Simplification is the key. And there's a thing what we call jugaad in India, like I'm born and raised in India, or what we call hack here. We call jugaad in India. Be scrappy in the beginning, start somewhere, and then you will refine these things. Try micro level models first, and then you mature your organization to start using more sophisticated models when it comes to machine learning, data science, deep learning. So with that, I think we can wrap up here. Bill, thank you very much.
Yes, sir.
I think there's more to talk about. Like we'll find another time. I wanted to cover the stakeholders a little bit more, practitioners, what types, there's a data scientist and data prep guys and all that stuff. Maybe we can cover that at some other time.
Yeah.
But with that, thank you very much. Appreciate your time.
It's fun. I enjoyed it very much. We went all over the place. Hopefully you can pull some good nuggets out of this.
Thank you very much, Bill.
Yes.
Appreciate it.
You take care. Thanks very much.